Welcome back to Mr. Gard's maths class. Today we're going to be looking at the area of basic shapes and how to convert units of area. We will begin today's lesson with just simply looking at the area of a square as seen on the left and the area of a rectangle as seen on the right. Hopefully you will already have a pretty straightforward understanding that to determine the area of a square, it is simply length multiplied by the length, as with a square all sides are the same, and we can also call that length squared if we like. While the principle for determining the area of a rectangle is the same, we often won't call it length times length because the lengths are different. So if we refer to this one possibly as the width and this side as the length, the area for a rectangle is therefore length multiplied by width. And they're two very simple formulas for the area of a square and the area of a rectangle. The next shape that we're going to look at is the parallelogram. While a difficult word to potentially say and spell, it is actually really quite simple to work out the area of a parallelogram. Just to remind you, a parallelogram is effectively a rectangle pushed over. These two sides are the same length and they also are parallel, right? Meaning they run in the same direction. These other sides are also matching in length and matching in direction that they are pointing. So they too are parallel. Hence the name parallelogram. As with many of our shapes, the way in which we determine their area is by changing them into rectangles. So I'm going to remove those little marks that I made previously, and we'll show you how we determine this as a rectangle. You'll see I've put a vertical red line in there, and I'm going to do the same over here. What you might notice is as I put this final little bit in, I have actually turned this shape into a rectangle if you focus on the red section. This part here actually matches this part here. So what we are in fact doing is chopping off one end of the parallelogram and placing it on the other side, thus making a just like this. This bit is removed and it is now placed over on the other side. You will notice that the base, the blue line along the bottom, has not changed, and we can call that L. And rather than use this distance, let's just call it D, we will in fact use H, which can be the height. So this is the key bit that you need to remember about a parallelogram, is that we actually use the height of the parallelogram and not the length of the angled side. The formula therefore is the length multiplied by the height. Now it doesn't really matter whether you call it height or width, it's just a nice one to refer to the vertical aspect of the parallelogram. The next basic shape that we're going to be looking at is the triangle. Again, you may have seen how to determine the area of a triangle previously, but this will be a refresher on what you most likely have seen before. While the basic principle of turning a triangle into a rectangle remains, what we should remember is that a triangle is actually half of a rectangle. So by determining the area of the rectangle that the triangle fits in, we can then determine by dividing it by 2, in other words halving it, what the area of the triangle is. I'm going to begin by placing this triangle inside a rectangle. You will now see that the green triangle fits inside the purple rectangle. Now the way we can show that the green triangle is half of the total purple rectangle is by following this. I'm going to use some dotted lines here just to, like so. Now you will notice that, let's try and use a green pen, this part here matches this part here, and that this part matches this part. Ultimately, we can see that half of the shape fits inside the green triangle, and the other half of the rectangle is outside of the triangle. Thus, we have two types of formulas, or one formula, just two ways of writing it. Sometimes you'll see it as half times base times height, or you'll see it as base times height divided by 2, both of which give the same answer. We'll go through one really quick example here of how to determine the area of a triangle. So as you can see on this magenta/pink coloured triangle, we have actually 4 sides, or 4 lines marked out. Around the triangle, the sides are 11, 5 and 10. And then you'll note that there's often going to be another side like the one that says 4, which is not really a side but gives you the vertical height of the triangle. Now, sometimes when you get these, you have to determine which sides are going to be important for you to work out the area of this shape. I'm going to draw a box around it, like so. Now, from doing that, you can see that we don't need the 5 or the 10. I've now created a rectangle with dimensions 4 as being the height and 11 being the base of this triangle. So, get my black pen. Area equals 1/2. This is all using the formula for the area of a triangle, multiplied by the base, which is 11, multiplied by the height, which is 4. Often you'll be questions will try and trick you, and they'll give you that dimension of 5 that we ruled out, and they'll try and get you to use that value. The area is therefore 1/2 times 11 is 5.5 times 4, which equals 22. Now in a minute we'll go through how to convert area measurements, but in this case let's say it was in centimetres, and because it's area, centimetres squared. As mentioned before, let's look very quickly at converting units of measurement. Now there are the set of loops that we had from our last lesson, converting kilometres to metres, metres to centimetres, centimetres to millimetres. Hopefully we have worked that out and we can remember it. Now when we are talking about area, we have squared units. So if you're going to rewrite one of these at the start of a test or at the start of a unit, when we talk about kilometres squared, that means it's a square kilometre, so 1,000 metres times 1,000 metres. In other words, there's 1,000,000 square metres in one large square kilometre. So what we do is we actually have to square all of these values, like so. And I'll give you a little example of how that might actually look. So I've drawn up a quick square. Now those sides are all the same. Let's assume that one side length there is 1 metre. So we're going to convert from metres squared to centimetres squared. So 1 metre is the same as 100 centimetres. So we can fit 100 little square centimetres. Now I'm obviously not going to draw them in there, but you might get the general idea. Because it's a square, there's 100 centimetres down this side. Like so, 100 down there. Now what we actually have is 100 lots of 100 square centimetres. So 100 times 100 is 10,000 centimetres squared, which is, as we wrote up here, 100 squared. Can seem like a lot, but you've got to trust the process. As is going from kilometres squared to metres squared, there are 1 million metres squared in 1 square kilometre. Now, one more little point that kind of doesn't fit any of these is we often, using in metric, we talk about hectares. Generally, we'll talk about hectares when we're talking about, say, the size of a farm. That's because a hectare is 100 metres by 100 metres, which multiplied together is 10,000 square metres. That's just a little point of note for when you do this work on area of basic shapes. This has been a long lesson. Thank you for listening.